And welcome to another episode of Let's Learn Zig. So today will be a pretty easier-ish kind of shorter episode of strings. We just kind of go over some of the basic stuff like how do you create a string, how are strings handled under the hood, because they're just slices of bytes, and then there's also the sentinels and null terminators that we'll get into a bit. So yeah, and at the end, the last code example, I try and show more practical examples, especially when it comes to formatting strings, because that's something you'll do all the time. Yeah, I don't really think there's going to be too much of an intro here, and the code will be pretty self-explanatory as I go through it. So yeah, hope you enjoyed the video. Okay, let's get into it. We're going to go through 5 different coding examples today, and we're just going to start by defining a string and printing out some kind of information about it. So let's say we have constant greeting. This is going to be our string, and hello. So this looks just like a string like any other language, right? It's just greeting, hello, nothing too fancy. So now let's actually print some information about it. So maybe like the type or things like that. So I'll just put a few in here that we will fill in. And then the type. And if you want to print a string, you can use this S specifier. And then we will also print the length. Let's see, we'll also have, what does byte maybe 0 look like? And what does the last byte look like? We'll have all of that. And let's look at how we get it. So obviously bytes 0 and 5 will just be like that. Get 0 and 5. The length will just be greeting dot length. And then the type, this one will be a little bit more. So type name and at type of, then we'll pass in greeting. So now let's run this. And let's see what we got here. So the type is a const pointer 5 through 0 and a U8. So what does this mean? So const pointer. So all strings are actually slices under the hood. So a slice is just kind of contiguous block of bytes. So we can see it's U8s. So it's like an array of bytes really, or a slice of bytes. So, and it's a const pointer because we cannot mutate it. If we had tried to do something like greeting 0 equals, so just say capital H, we try to run it, we get a compiler error, cannot assign to a constant. We'll get rid of that and rerun this. So yeah, so we see, so constant, that means we cannot mutate it, and pointer because it's pointing to the slice. And what is this 5:0? So the 5 is, well, it's the length, right? So if we go back over here and we look at hello, it's just 5 bytes, right? But then this :0 means it's null terminated. So it has a sentinel at the end. So what that means is that, well, if you go back to like a slice of bytes in C, for example, it would look something like this. So we would have H, E, L, L, O, and then for us to actually know its ending, it needs a null terminator. So that when we go and print and anything like that, it'll just print all the bytes until it reaches a null terminator. So that's essentially what this is saying. We're saying it's null terminated. We can see that we can actually look at that here. So see how when we go to byte 5, you'd think, because remember this is 0, 1, 2, 3, 4. So it doesn't actually error when we go to byte 5. And that's because there is something there. It's that null terminating character. So if we had tried to do like 6, for example, and run that, we see index outside of array 5 plus 1, which is that sentinel. So you can kind of index and print into that sentinel. One more time, and then obviously byte 0 is H, and the length is 5. So when we do length, we actually don't count the sentinel, because technically there's a byte of 6, or there's a slice of 6 bytes, 5 for hello, and then plus 1 for that sentinel. But we only actually do it for, or like print the length of how many bytes are in the string itself and not the sentinel. So I hope that makes sense, and we'll move on to the next example. And now let's go to the example of actual constants and mutating and how we can mutate a string. So let's go with a simple one. So this is just another way to write a string. So this is exactly equivalent to this, except the only difference is it's saying this can be kind of any length. It'll interpret it from whatever it's assigned to. So it's essentially the same thing, but just a tiny bit different. And now let's just do a quick print, debug, print. So we'll say this string has the bytes. And we'll do a and a dot length. Let's make sure this runs. And the world has 5 bytes. So that's expected. There's 5 things here. Same as last time, right? So let's say we actually want to copy. So what is going to happen? So we have const b equals a, std debug print. And then we're going to look at the underlying pointer being like, are they the same data? Right? And then we'll look here. So we'll do a dot pointer equals b dot pointer. So what does this look like? We run it. Say, are they the same data? So what's happening? So when we do this, we're not creating a copy of A and putting it into B. So they are just both pointing to the underlying data, because a slice is actually just, it's a struct that has a length and a pointer, which is probably like a U64 or something like that. So this is what a slice is. And that's why we can do like dot length and dot pointer, because this is what a slice looks like, right? So when we do this, we're just copying the outer struct. We're not copying the pointer of the data itself. So when you do b equals a, you're not doing a copy into world, but you're actually just copying this. So then you have 2 structs which have the same pointer. So these 2 values are just the exact same in a and b. So how do you actually mutate something? Well, let's look. So if we do buff, we'll just take 5 U8s and start it off with undefined. Then do a mem copy, buff and world. And now we can say const mutable U8 equals a reference to that buffer. And now we can actually copy it, or mutate it, I mean. So std debug print mutated and then mutable. Okay, so what happened here? So the biggest reason why we can mutate it is you might be confused. You see this constant and you're like, well, but you can't mutate something that's constant. Well, that's because we didn't say the struct was constant. Notice up here, we have the const also right over here. So let's just first run this. And we can see it's a capital W world. So mutating worked. But now if we had made this a const U8 or a const slice, then it would fail to compile, and same with the cannot assign a constant, right? So let's undo that. So what happened here? So now we actually did a mem copy of world into mutable, and we printed it. Okay, and let's make this example a little bit more interesting. And instead of copying the string, let's copy A. And then at the end, we'll also print A. So when I was saying before, if we mutated, like in this case, if we mutate B, it would also mutate A. But now we're doing a full copy, a mem copy of A. And now let's see what happens. So we can see mutated has the capital W, but A has a lowercase. And that's exactly what we want. Okay, next example. So I just want to quickly show how bytes are not just characters. Like for example, this is a special E, which actually takes 2 bytes. So if we were actually to do a debug.print the length, and then do s.length, we just quickly run that. See, it's 5, even though there, you see like there's 4 characters here, right? It's actually 5 because this E is taking 2 characters. So now if we, but let's say you're running code and you just want to know like how many code points it is. So in this case, it's 4. Zig does have a way to do that. So let's do count. Let's try std Unicode UTF-8 count code points. And now if we do that, dot print count, let's print that out. And then it's 4. So we can see if you do want to just count exactly how many characters there are, you can use code points from UTF-8. Okay, so now I want to show an example of equality. So if we go over, I want to show how we can't just use the equal sign. So let's do this. And then let's do just A equals B. So what's going to happen? Well, it's actually going to fail to compile. And that's because the operator equal equals is not allowed for a slice. Remember earlier what we had done, we did like dot pointer and dot pointer, right? And that works if you want to look at just the underlying pointers are the same. But let's say we want to go byte for byte. Are these the exact same? Well, you're actually going to use something in the standard library called equal. And we're going to be comparing U8s. Because remember, strings are just slices of U8s, an A and B. So if we run that, we can see they're true, right? Because all it did was a byte for byte comparison, like Z equals Z, I equals I, G equals G. And then that's worked. So let's just show kind of a couple more examples here of starts with and ends with. So instead of equal, we'll just do starts with, and let's say Zig Lang does it start with Zig? Or ends with, does Zig Lang end with Lang? So if we run that, we can see true, true, false, and that's because I didn't do this, ends with, right? So let's do that, and then true, true, true. Okay, and then one more I want to show is, let's just say a common one is you need the index of something. You can do index of, then it's always the same. You put whatever type it is. Hello world. Let's say we want to try and find the index of world. So we take that index and then let's just print it. Dot print index of, and then the index. So if we run that now and we see the index equals 6, so let's just validate that. So we have 0, 1, 2, 3, 4, 5, 6, and that's exactly where it starts. Okay, let's get into this last example. So it's going to be the most useful one because this is probably going to be a very common case, and that's just interpolating values into a string. So what does that look like? So we have a message. We can do std.mem.eql alloc print, and then you'll need your in allocator, and then say hello. Just say S, you are number D, and then we'll take our args, and we'll have something like, let's just say Zig and 1. And then of course you have to defer freeing it, free the message at the end, and then let's just print it. Debug print alloc print, is this S or a string, and then we'll print it on the street. And if we run it, there we go. Hello Zig, you're number 1. So it interpolated Zig and 1 into this string and then create it. So that's the case. It does use a heap allocation. Obviously, we passed in an allocator. That's because it was dynamic. Like this string we passed in could be any size. We don't know. Let's say you want to keep it all on the stack. You know you have a max buffer size. So let's show what that looks like. So let's say you take a buff and just 64 bytes. Undefined. And now we can do line. Let's try std fmt. This time it's going to be buff print because we're going from a buffer. So pass that buffer in. And now we'll do like D plus D equals D. And we'll do 1, 2, 3. And now we don't have to free it because it's not on the stack, or it's on the heap, it's on the stack. Debug print. Let's do buff print. S. And then we'll just pass the line. So now if we run it now, we get 1 plus 2 equals 3. Do you want this to be a kind of better example? We just do 1 plus 2 right in there. And then 1 plus 2 equals 3. There we go. Okay, so this next one will be actually pretty interesting. It's going to show kind of the equivalent to a string builder in other languages. So let's do a string builder. This time we're going to do std array list of U8s. It's going to start empty and defer sb.dinit, pass in the allocator. So now let's actually kind of build the string. So let's say that like you have to iterate over data and you don't really know what you're going to have. Look.gpa, and then say it's build, append. In this case, it should actually be slice, and then append build me, and then in this case, we just do append, so it's a single item. So we just do a single character. So append slice will obviously be a full slice of, in this case, U8s. Append is just a single U8. And now let's print it. So std debug print the array list approach. And then what we do is sb.items. There we go. So we have the build me. We can probably get rid of that space. And we run it. There we go. So we have our alloc print, our buff print, and then our string builder. I hope you enjoyed the video. This was, again, is just strings, but strings are a little different in Zig than other languages just because there's no string keyword. There's no std string. It's just you're using slices of bytes, just like C. And it's not too bad when you get used to it. If you're coming from like Python, even Java, or like anything like that, it may seem odd that you don't have like first-class string support, but you don't really need it. It's just a buffer, just some bytes. It's not too bad. But yeah, I hope you enjoyed the video. If you did, leave a comment, like, subscribe, all those things really help the channel. And if you want to chat more, as always, there's a link down in the description for the Discord server. But yeah, that's all I have, so have a great day.